Alright, time for another DraftPhysics.com, debatephysics.com also. But the cowards won't debate the actual subjects or counter the actual arguments. They were just going to keep pretending they don't exist, and they'll just use a little, word salad jargon, whatever you want to call it, to evade the basic subject of something hits something else. And they'll say, well, you have it in the wrong units. Well, I don't have to have units. I just hit something and we can watch what it does. We don't even need a unit, because we can see it happen. Okay, so anyway, not that I'm opposed to doing your math correctly. I'm just saying it's all about relationships. 3 to 1, 5 to 1, 6 to 1, whatever. And units don't matter. They don't change anything. So in the case of... So anyway, so MCToon says that 1/2 mv squared doesn't mean that... I guess I could get... He also says, oh, what, he shot a gun in the lecture? Yes, he did. Okay, so he pretended the experiment didn't happen, because I brought it up. No, somehow it didn't happen. When, yes, it did happen, and it happened the same way it always happens. 99.94% of the kinetic energy was destroyed, that's what he said, as heat. Okay, but no one collected the heat, so that's just made up. That's like the heat of the 5-ton train hitting another 5-ton train and becoming a 10-ton train. We just drop a weight on it, and they claim that half the energy was lost to some sort of deformation when all of the momentum was conserved. So somehow we deformed something and we didn't use any momentum. Yeah, so it doesn't take any momentum to crush fenders. No, it's free. See, they don't deal with the actual experiment and the actual arguments about the experiment. All right, so he's saying that 1/2 mv squared, okay, doesn't mean that it takes, say if I put a 2 in here, this will be a 4, right, for energy. All right, I put a 4 in here, it'll be a 16. And I put a 5 in here, it'll be a 25. So that's exactly what the square means, and there's no way of avoiding it. If it produces 25 units of energy, that means you had to use 25 energies of fuel to make the event happen, because we all know there's no free energy. We all know it in theory, but obviously you think in practice there is such a thing. All right, so it's an insipidly idiotic argument to make that the v squared doesn't mean a quadratic increase in the product. Okay, so he's just wrong. Not a single one of his commenters would tell him he's wrong. What is that but a religion? I mean, he's absolutely wrong about what the formula requires. It's just a fact. The formula says the 16-pound bowling ball going 8 miles an hour has half the energy of an 8-pound ball going 16 miles an hour. It's an absolute fact. It's what the formula says is true. So why are you running away from what the formula absolutely says and then saying we're right? Does that make any sense? No. All right, so early on in the Afterbirth show, it really was a bloody placenta. There was a guy called, I think, Clive, and some Astro something, and they don't have channels, so I can't direct this at their channels. But anyway, MCToon kept interrupting them, trying to make their argument for him, saying things that were just stupid. So he said that the rocket thrust proves kinetic energy. So let's do that one first, and then we'll do the ballistic pendulum. But the two stories are exactly the same. The two experiments are illustrating the same thing. This actually is in the video where he shoots the gun. It's called impulse in rockets. So I mean, he's using a ballistic pendulum. He's firing a gun. So ballistics is the same as rockets and all the rest of this stuff. So anyway, so I have a rocket going to take off. So I stated, I like using the example in empty space because it makes the the whole subject so much easier. And the fact is it produces exhaust. Now, what physicists do is they'll make up how much power the fuel has. So they have a rocket equation that doesn't have anything to do with how much energy the rocket gets. It has to do with how much fuel is producing what thrust. And they just make it up. But the simple argument is if we reduce the thrust to something simple, and we just say it's, little pellets, and they're going to move a specific speed. So there's 100 grams of pellets, and they're all going to move 10 miles per hour. It doesn't really matter what we use. All right. And the simple truth is that's a momentum. So let's just say we calculated the momentum of the thrust based on it being little objects, and it came out to 100. All right. The simple truth is that's the momentum the rocket will leave with. So whatever the thrust is in momentum, mv, whatever you make it out of, baseballs, it doesn't matter what the thrust is made out of. It's little particles that have a mass, and they're going to move a velocity, and there's a certain number of them, a volume. And you just calculate that, and that tells you exactly how much energy the rocket will acquire. And that's Newton's third law, because it's momentum. And the absolute truth is if this is 100 in momentums, it's likely that if you calculate the kinetic energy, it might be 10,000. Okay, because it's very fast little things. So the smaller I make the particles, the more outrageously large this number gets, because it's a v squared, right? I mean, how many times do you have to go over that? It's v squared. Pen's running out. It's really important. Yeah, so you can understand that as I make, just like with the 16-pound ball going 8 miles an hour versus the 8-pound ball going 16, every time I change the momentum, right? It's the same amount of a momentum, but I change the ratio of mass to velocity, I start increasing and decreasing the amount of kinetic energy. So obviously I've used very tiny particles and I move them very fast. I'm going to get a big, giant number here for what the kinetic energy is. And this rocket will not acquire that number. So whatever this joule number is here, the rocket is not going to go that number. So there'll be a huge amount of waste, where 99.94% of the rocket's thrust and exhaust will not produce any movement in the rocket, because the rocket can only do the momentum thing. The only thing that can move the rocket is momentum. So Astrokate is supposed to be a NASA scientist, and she doesn't know this truth, that Newton's third law only applies to momentum. It's the only place it works. I mean, whether you know it only applies doesn't matter, because there's no example of it working any other way. Okay, there's never an equal and opposite reaction unless I use two masses that are exactly the same. In every other circumstance where I have an explosion and I have different masses, I will not get the same amount of kinetic energy going this way as I have going this way. It will never obey Newton's laws. It won't obey the third law. Only the momentum will obey the third law. So the fact is the only thing that can move this spaceship, give it velocity, is the momentum. And the same is true for the ballistic pendulum. So the bullet, and again, this wasn't even a tiny bit challenging. I made no mention of anything about the gun. No one's measuring the gun's recoil. And I made the simple statement that every scientifically literate person on Earth right now would not disagree that Newton's third law applies to the momentum, that the gun recoil will have the same MV as the bullet as a total amount. Yes, it's a different proportion. It's, let's say, 1 atom, okay, moving 100 velocity versus 100 atoms moving 1 velocity. It's always going to be in that ratio. They're always going to be the same MV. The same MV going this way will be the same MV going that way. And that's just a I shouldn't have to prove that to somebody by having some dopey experiment where they measure both of them. Because we know every cart experiment with a spring, every experiment, Feynman did it with a little explosive. That every single time the experiment's done, that's how it turns out. There's just no doubt about it. So I shouldn't really have to argue something as trivial as that with people claiming to have physics knowledge. So that simple fact is a fact. And the fact I argued is you have a bullet with, say, 2,000 joules of energy. And when they go to collect it, okay, they collect 1.8. So they almost collect all of the momentum. So the momentum is 2. Okay, so the momentum's 2. The kinetic energy is 2,000. Now I'm just using numbers, but it fits for like something going 200 miles an hour. And the bullet, I think, in this experiment went 244 miles an hour. So we know the gun has 2 momentums, okay? And the fact is its joule number is going to be 2 because of the fact that it's the v squared thing. It's going to be going 1,000 times slower. The bullet's going 1,000 times faster, so it's obviously going to be 1,000 times difference in the amount of energy they're calculated to have. So it's a gigantic disproportion. And the simple truth is, though, is how else could this turn out? Now, Professor Lewin does say, I'll play the clip, he does say that this is destroyed kinetic energy, but it's destroyed as heat. But we know we can collect heat. And if I collected the heat, the 1999 joules of heat, okay, and I turned that into momentum, well, then we'd have a real problem here, right? Because now I'll be collecting more momentum than the bullet had. The bullet only had 2 momentums. If I start adding thousands of joules of energy to the equation, to the pushing force on the then all of a sudden I'm going to have a problem where how did I make free momentum? And then we're right back to the other Professor Lewin experiment that he wouldn't. He proved something for their side when I clearly made the point that what the experiment illustrates is free momentum. And I want an explanation for how you think it's possible that I can put 100 momentums in and I can get up to, so if I put the right weight, 199 momentums out in the same direction. Yeah, that's their theory. That I can somehow have an interaction that inputs no new energy, and I can just convert a heavy thing with 199 momentums. I could just make free momentum. By banging a light thing into a heavy thing, I could just make free momentum. And I could do that over and over and over again and just keep increasing how much momentum I'm creating. And they say that nobody's used that or capitalized on that, and they don't give me any reason why they wouldn't. It's free energy. It's more force. It's more pressure. Any circumstance where you want to create pressure, weight, you'd say, shit, I'm getting free weight. I'm getting free pressure. Why wouldn't I use it? Jackhammers, all kinds of things. You would say, yeah, sure, that's what I'm going to do. All right. But there's no evidence they do that. So it obviously doesn't really happen. All right. So let's play some of the Lewin clip. But there's no, I'm just saying their responses were obstinate and belligerent, and there wasn't anything about it that was responsive to my actual argument. That it really means something. To be able to argue these points and say, okay, you can't just say there's magical kinetic energy in the ballistic pendulum and then not explain how, well, if I collected it, then I collected free momentum. Again, I hate to go back to this old, but it does solve the whole problem because it just points out how what they're saying is impossible. So this is the other experiment you can do. You have a 5 mass, you give it a velocity, then you add 5 mass to it gracefully, and then it continues on as a 10 mass, okay, with exactly 1/2 the velocity, and it comes out almost exactly 1/2 of the velocity. You lose almost nothing. Almost nothing. It's a perfect conservation. And their argument is that somehow 1/2 the kinetic energy is gone. So they can't just say it's heat. They can't just make up some crap. And they certainly can't say deformation, because you would certainly understand, well, deformation has to be made by momentum. So I can't have 100% of the momentum over here if I use some of the momentum to dent anything or make sparks or knock a piece off. That's all obviously going to require momentum. And the simple argument is you can't make heat without using something's momentum. There's no way to generate heat without something having momentum causing the heat. And they think that's a nonsense statement. And I'm saying, well, you're going to have to demonstrate or draw it or explain how that's nonsense, because it's entirely logical and completely consistent with every experiment that can be done that creates heat. I can show you where the momentum is. Electrons moving through a wire, momentum. It's always momentum that causes heat. So you can't conserve all of the momentum in the motion of the cart and then claim I also dissipated momentum as heat, or I dissipated it as a piece flying off in some other direction. That's again free momentum. Where did it come from? I mean, these really are good arguments, and they really should have the integrity to address them in a rational and serious manner, and they won't do it because they're not really interested in the truth. Okay, so let's just play some of this. I probably can fix the volume a little bit. Yeah, that's good enough.
Put the bolt in, the bullet's in my pocket. There's one. That's right. There comes the bullet. And I cock the gun. Everything done right, yes? So you can look there and then see the swing of this very massive block, and the bullet will get absorbed in that block.
So the irony is the gun is essentially the same thing as the ballistic pendulum. So they could put the gun on strings and they could do the same exact measurement. It's kind of a heavy mass. Half of the energy is going to go into that heavy mass. The other half is going to end up in that ballistic pendulum. And it would be even more obvious that you can't say the energy is somewhere else. So the gun's going to get the same momentum that the ballistic pendulum has, and that's all the energy there was, and that's all the energy there is. And this argument should be addressed by anybody who's going to say their physics is reasonable and rational, because this is paradoxical nonsense. To argue that the kinetic energy is playing a role somewhere, it's doing something, it's obviously not doing anything. Nothing. It has no role to play because it doesn't exist.
You ready for this? 3, 2.
So unfortunately, do all close-ups and you can't see the pendulum, so that sucks.
1, 0.
So that's the little marker.
I would say 5.2 centimeters. Seems to me about right.
So that was kind of
so
a
X
bummer.
Observed.
All right, so you can see the pendulum moving. Okay, it's got a little hole in it where the bullet went in. And so now he's just going to calculate the speed of the bullet based on this. So let's just go to the point where he makes the argument about the fact that you lost everything.
Last time we had something very similar. So the speed of the bullet is about 244 meters per second. It's a little under the speed of sound, which is 340 meters per second. And we came to the same conclusion last time.
Yeah, he's a little bit
All right.
reading his notes, blah, blah, blah.
1/2 mv squared. You can also calculate how much kinetic energy there is when this bullet is absorbed in here. That's very easy.
So obviously it's a gigantic amount of kinetic energy in the bullet, and there's almost no kinetic energy in the ballistic pendulum.
That's 1/2 times the total mass, m plus m, times v prime squared, which you also know now. And so you will see then, perhaps to your surprise, that if you compare the two, that 99.94% of all available kinetic energy before the collision was destroyed and therefore was converted to heat.
So he says it was converted to heat, but there's zero evidence that there's 1,900 joules worth of heat in that clay. And the argument would be is if you collected it, then you'd have to explain where the momentum came from. So obviously they're a little short in conserving the momentum, so there is some heat. So some of the momentum was used to make heat, but it's just a little tiny percentage. So I'm just saying the experiment, you can see it for yourself. The fact is kinetic energy doesn't do anything useful. So in fact it can't turn a spaceship. He's basically proved it right here, because there's no way to collect it. Something can impact my spaceship with a huge amount of kinetic energy, and just like the ballistic pendulum, my spaceship's going to be unable to collect any of it. It can make heat, but I can't collect the energy. I can't be turned by it, because I can't turn it into momentum. Because if I turn it into momentum, I'll make free momentum. If he collects more than that tiny, tiny percentage of kinetic energy in the ballistic pendulum, the 0.6%, the 0.06%, if he collects any more than that, he's going to start running into a free momentum problem. All right, so that's probably enough. But I mean, again, it was all distraction and distortion. So if you people had any integrity, all these raggy commenters, all the nonsense that went on in that debate, this is, and to pretend these aren't real subjects, that it's a real issue, that your stuff called kinetic energy can't do work, and that's the argument. In none of these experiments does it do work. And yet you're insisting it's vital to physics. So even if it existed, you're clearly accepting the idea, well, it's a scalar, and it went in all directions, and it went to heaven. It's heavenly energy. So it doesn't have to actually go into something else. It doesn't have to be transferable. Then what good is it? If you can't transfer it, if I can't transfer the kinetic energy of the thrust into motion of the spaceship, why are you telling me I have to pay attention to kinetic energy? If the momentum's the only thing that's going to get me that equal and opposite reaction, why would I want any other kind of energy? Why would I use something that can't get me that equal and opposite reaction? Yeah, I'll leave it there. So it's, you either show some integrity and deal with the real arguments, or, yes, I have a right to say you're cowards, and you're liars, and you're shysters, and you're propagandists for a fucking religion. Because you don't have any physical evidence. Any physical evidence that fits in the category of clean and without paradoxes. Yeah, it's good enough.